This is Webdev Sumos, and today we'll be looking at two questions from Stack. The first one that I'm going to try to solve is the baseball game, and let's see what we can, how we can solve it. Okay, so baseball game. Sorry. The question is like this: you are keeping the scores for a baseball game with strange rules. At the beginning of the game, you start with an empty record. You are given a list of operations where operations of I is the ith. You're given the list of operations where operations of I is the ith operation you must apply to the record and is one of the following. Okay, an integer x record a new score of x plus records a new score that is the sum of the previous two scores, records a new score, records a new score that is the sum of the previous two scores, d a new score that is the double of the previous score, c invalidate the previous score removing it from the record. Okay, so let's see, you are given the scores for a baseball game with a strange rules. At the beginning of the game, you start with an empty record. Okay, you are given a list of operations where operations of I is the ith operation you must apply to the record and is one of the following. An integer x record a new score of x plus a new score that is the sum of the previous two scores. Record a new score that is double of the previous score. Invalidate C, if C comes, invalidate the previous score removing it from the record. Okay, I see what's happening. Return the sum of all scores on the record after applying all the operations. Okay, the test cases are generated such that the answer and all intermediate calculation fit in a 32-bit integer, and that's all operation and that all operations are valid. So all operations are valid, meaning we will get to work on something. So my question is, at any given point, if plus or d or c comes, will I have a value to work on? That is what my question is. So I'll basically explain what the question is trying to say. So there are operations given to us, okay, and whenever there is an integer, we record a new score basically, and whenever there are three operations that I'm looking at, which is plus to add two previous records, a d for doubling the previous score, and c which is to invalidate the previous score. Okay, so these are few of the operations. So what I can see is there is a already they have given us the operations. So when phi and 2 will come in, phi or 2 are there, uh, we record them, and when c comes we have to remove the previous score, so 2 will get removed. Then d comes, phi is to be doubled. Oh, so 2 phi's are 10 to the record is now phi and 10. Then add, record a new score that is double. Okay, we have to record a new score, so 10 is the new score, plus add 5 plus 10 to the record and record a new score that is the sum of previous two scores. Okay, got it. So okay, I've got two score, the total sum is okay. And later on, whenever when all the operations are done, we have to do the sum of the of of whatever is remained in the stack, right? Got it. So basically, if this is a stack question, so what I'm thinking is, whenever we find a value, we'll store it in the stack, and whenever a certain operation will come, we will just empty the stack from empty this. If C comes, we will empty the pop the stack last element. If T comes, we will take the take the previous, like the last element, and multiply it with 2 and then add a new element. If plus comes, we'll take the last two records and then add them up. Okay, so that's what I'm basically going to do. What I have to do is let op of operations, I'm thinking of looping through this, and let stack is equal to an empty. So basically what I was thinking to do is that keep a track of the sum, so that we don't have to do the entire calculation again. So that's what I'll be doing here, right? Okay, so if op is equal to plus, okay, what we have to do is we have to take, let x and y would be equal to operations, okay, stack of stack dot length -1, and this would be stack dot length -2. We have to take this in x and y, then x, let temp is equal to x plus y, we have to add them, and basically add them to sum as well, total sum as well, total sum plus equals to temp. Okay, and we also have to add this to our stack dot push, our total not total sum but temp. Yeah, else if our op equals to t, then what we gotta do is take the last element, let x is equal to stack stack dot length, stack of stack dot length -1, and let x stack yeah, what do you do is x is equal to stack, we have to double it, right? So x is equal to 2 into x. Okay, so what we do is total sum plus equals to x, and we also stack dot push, we add temp, sorry, not temp but x to it, and else if op is equal to what do you call it, c, if it is c, then all we have to do is let x is equal to stack dot pop, remove the last element that we have added, last score that we have added, then total sum minus equals to the x that we have just found, okay, and that we just popped, and that would be it. Else if it's neither of them, then it should be the value. So everything is a string, right? Everything is a string, so we must convert it to a number. So before pushing to the stack, let x is equal to number of op, and once, and then total sum plus equals to x, and stack dot push x. Okay, so that should do it. And basically once we are done with this, looping through everything, we can just return total sum. I hope I have got the gist of what has been asked here, and I've coded it out in like of n time. So yeah, basically for all operations we have to do this. Let's try and run it. Yeah, so this is accepted, and let's submit it. Okay, cool. So it ran, and I guess so the time complexity of this would be obviously of n, because we are traversing everything in the operations array, where n is the length of the items in the operations array, and the time complexity, the space complexity of this would be we are storing storing the storing everything in the stack. So in the first case, if no operations are there, just numbers are there, everything is number, then everything is a score, then we'll be storing everything in our stack. We'll be never popping or anything of that sort. So of n would be the worst case time complexity of this. So yeah, let's mark this one, and where is my stack? So let's add it to stack, and let's also see how many times this question has been asked. So not a lot, not a lot, not a lot of time it has been asked. So it's a pretty basic one. We can just tick mark it. The next one that I want to solve is removing stars from a string. So let's give it a try. Looks like I've already solved this one, but I don't remember it. Okay, so let's see what the question is asking from us. So you are given a string s which contains star. In one operation, you can choose a star in s, remove the closest non. Okay, in one operation, you can choose a star in s, remove the closest non-star character to its left, as well as remove the star itself. Return the string after all stars have been removed. The input will be generated such that the operation is always possible. It can be shown that the resulting string will always be unique. So I suppose whenever the star appears, there will be always a character on the left. So, and okay, got it. So I guess what we have to do is, so LEET is there, then star comes along, then T is removed, then another star comes along, E is removed, then COT, then star comes along, D is removed, then E. Okay. Okay. So what can we do in this case? Yeah, basically if this is a stack question, so what I'm thinking in terms of stack. Let's say we are thinking in terms of stack. So we'll have a stack where we'll be looping through this entire string. Whenever we find a no, whenever we find a string character which is not equal to a star, we'll keep on pushing that letter to the stack, and as soon as we identify a star, there is a star in our string that we are iterating, what we'll do is pop a letter from the stack and keep on iterating. Whenever we identify a star, we'll pop one letter and continue. So by the end, whatever will remain in our stack will 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 iterate through it and create a string out of it. So yeah, that can be done with the help of like that. That's the brute force approach that I'm thinking right now. That would be eventually of n time complexity, which is the length of the string. Okay, and space complexity. Um, Worst case, we won't end up with any stars. So of n. So yeah, I guess this should work. So I'll explain this process to the interviewer before proceeding with the code, and if he or she agrees, if the interviewer agrees, then I'll start coding. So in this case, I'll just code this out, and let's see, stack is equal to an empty array, and okay, and what we'll do is we have to traverse through the entire, let's call it character of s, and if let's add in some space, if character equals to um, if it is not equal to star, right, what we'll do is stack dot push that character onto the will push the character onto the stack. Else, if it is a star, then all we have to do is stack dot pop. Okay, so basically it's just that. And then lastly, there is a uh, trick in JavaScript. You can simply do stack dot join and uh, uh, put a split delimiter, which will kind of join how you're going to join it. Then basically we'll return this, and I guess this should work. Eh, but for a medium question, this looks pretty easy. I'm not sure if this is what has been expected. Okay, yeah, it does work, but the time complexity is, can it be good, because it just beats 15% of people. Can we do better than this? The question is that companies that, oh, not a lot of companies have been asking this question. This question seems pretty uh, not that great, but still, if we have solved it, it's a good question to just practice stack. So we'll mark it. Uh, but is can we do better than this? Because the string length can be up to 100,000. Yeah, 100,000. So it's a pretty big number. But of linear time, we are doing everything in a linear time, so I guess that shouldn't be that bad. Um, so let's see editorial. Let's not waste more time on this, and let's see what all method that they are. So yeah, space and strings. So what is this? Answer whenever there is a star. Um, then pop back. What is pop back? So yeah, the two pointer. So basically everything is performing this in O of n and O of n time. So O of n time space complexity. So I guess if we can come up with this approach in a interview, that should be good. So that takes care of this. I solved two questions, but it feels like they are not that good enough of a questions. Because it's just been 21 minutes and uh, we solved both of them. So what do you say, guys? Should we uh, so we did as I decided. I've done Leetcode baseball and remove stars. So yeah, I did what I promised. And next, I wanted to start with the binary search. So I was thinking of doing two questions from binary search. So which one should I be doing? Search insert positions, guess number higher or lower. These are all, so binary search is a pretty good questions that we can do. Single element in sorted array. We can do search, insert position, and single element in a sorted array. So hang tight. We'll be back in 10 to 10-15 minutes, and we can get these two questions solved. We'll try to solve these two questions in the next one, and after that we'll also jump onto the linked list and solve two questions from these two. Okay, that should be good.